This lesson is titled Introduction to Relations and Functions. Our objectives are first to identify relations and functions, find the domain and range for relations and functions, and use the 5 ways for representing relations and functions. A relation is defined as a pairing of 2 elements. Relations can be expressed using ordered pairs, such as x and y. In mathematics, we expect the ordered pairs to be numeric values, such as 1, 2. However, the pairings can be any 2 pieces of data. When you have a collection of ordered pairs, they form a relation. The first element of the ordered pair is called the input, and it comes from the domain of the relation. The second element of the ordered pair is called the output, and it comes from the range of the relation. So here we see we have an input and an output. The input comes from the domain, the output comes from the range, and often we see x comma y. Again, x is from the domain and represents the input, and y is from the range and represents the output. Our first example of a non-numeric algebraic pairing would be a relation of US senators to their states. So we see that in the domain we have New Jersey, so that's an input value, and the output could be Cory Booker, and that's from the range, which is the collection of senators. We have another ordered pair that starts with an input value of New Jersey with an output value of Bob Menendez. So these are 2 different ordered pairs that exist. And we can go on and look at all of the different states from the domain and all of the different senators from the range. So we see that the states, New Jersey, Pennsylvania, and New York, are the domain for this relation, and that the range, Cory Booker, Bob Menendez, Pat Toomey, and Chuck Schumer, are from the range in this relation. A second non-algebraic example could be the pairing of automotive makes to their models. So in the input value, we have Ford, which comes from the domain, and from the output, we have Mustang, which comes from the range. And again, we have an input of Chevy with an output of Camaro, an input of Chevy with an output of Corvette, an input of Dodge with an output of Challenger. So we see that the first elements, the X values, are Ford, Chevy, and Dodge, and they belong to the domain. And the second elements, which are the outputs, we have Mustang, Camaro, Corvette, and Challenger, and they belong to the range. Relations permit the pairing of multiple elements from the range with the same element of the domain. Notice that Chevy showed up multiple times here. This is not permitted for functions. Functions can only have one domain to one range and not the same domain connected to many different ranges. So, for example, I can have 1, 2, and I can have 2, 3, and I can have, let's say, 3, 2. This would be an example of a function because the first values are all different. It is okay that I reuse values for the output. It's still a function, even though I'm reusing the number 2 in the output from the range. But the values from the input must be unique. Okay? So the input values must be unique for it to be a function. If the input values are not unique and they're being reused, then it is a relation. So a function is a special kind of relation with the property that each element of the domain is paired to exactly one element of the range. Some examples are a collection of student IDs with student names. The student ID must be unique. The student names, there could be multiple students with the same name, and that's okay. So using the same value over from the range is okay. The domain must be unique. Example 4 says a collection that pairs planets with the quantity of their moons. Each planet name must be unique. The quantity of their moons could be repeated for different planets. That's okay because this is from the range, and we're allowed to reuse values from the range. So examples 3 and 4 are examples of functions. We have 5 ways to represent relations and functions. The first is set notation. Sets are collections of data, usually contained as lists within braces. So you'll see the braces here at the end. And here we have a list of ordered pairs. When relations and functions are represented as lists, they often depict as ordered pairs contained within braces, such as what you see here. And we have x1, y1 represents the x and y value from point number 1, x2, y2 represent the x and y values from point number 2, and so on. I can give an example. Let's say 1, 1, 2, 3, negative 1, 5. And this would be an example of a function because each domain value is unique. Next are mappings. A mapping is an arrow diagram that links the elements of the domain to the elements of the range. The image shown can be used to create a set of ordered pairs and determine whether the mapping is a relation or a function. So we see that the arrow starts at 2 and goes to 11. That means that the first number in the ordered pair is 2, and it is being paired with the number 11, and that's what we have here. The next arrow goes from 1 to 7. The third arrow goes from 1 to 14, and the fourth arrow goes from 3 to 9. So we created our ordered pairs. We see that we have an element of the domain that is used more than once. So that makes this a relation. Another way to represent relations and functions is through tables. Tables are useful tools for organizing data into ordered pairs. From here, we can say that this is the ordered pair negative 1, 5, and then next we have the ordered pair 3, negative 2, and so on. When discussing relations and functions, it is common to name the first column x and the second column y. Again, x represents the input values, which come from the domain, and y represents the output values, which come from the range. We see here that all of the x values are unique, so this table is an example of a function. A graph is a picture representation of a collection of ordered pairs. We plot the points on the coordinate plane with a horizontal axis, which we call the x-axis, and a vertical axis, which we call the y-axis. And again, the x-axis goes to the domain and the y-axis goes to the range. This graphical representation provides a visual that helps us better understand the difference between a relation and a function. Recall that relations permit the pairing of multiple y values to each x value, but functions do not. This can be illustrated using what is known as the vertical line test. The graph below contains a set of ordered pairs that can be classified as a relation. It is a relation because at least one input value has multiple corresponding output values. So we see the input value 3 is paired with 10, and the input value 3 is again paired with 5. This concept can be demonstrated graphically using the vertical line test. If a vertical line can touch more than one point anywhere in the graph, then the graph is a relation. If this were a function, then there would be no place in the graph where a vertical line can intersect 2 points or more. Next, we have equations. Equations are used to generate output values that correspond to the input values from the domain. Typically, equations are written using y equals form. But since we are studying equations in the context of functions, the y variable is replaced by function notation. So, for example, the equation y equals 2x minus 1 is expressed as a function by replacing the y variable with an f of x. F of x replaces y. Some comments that follow this description of equations is, first, f of x is the function name, and as you've heard me say, it is read as f of x. The function name is useful when handling multiple equations. Instead of having multiple equations called y in a graph, one could be called P of X that represents population. Another could be called R of X that represents revenue. And having this different naming convention allows us to uniquely address what each graph represents and how to refer to it when having a discussion about the graphs. For the value x equals c, where c is a real number, we would say that f of c is the y value that results when x is replaced by c, and we evaluate the equation. So in the example above, we have f of x equals 2x minus 1, and if c were equal to 1, we would say f of 1 is equal to 2 times 1 minus 1, and when we simplify that, we say f of 1 equals 1. So this is the f of c that was being discussed here, c being the number 1, and we're saying that this is a label and it is equal to 1 because that's the output. An ordered pair can be written using x comma f of x or x comma y. They are the same, but we want to transition to x comma f of x. We want to replace the y value with f of x or g of x or whatever function name would best represent the equation so that we have a unique way to address it. Example 5 says, given the function f of x equals 3x minus 2, evaluate f of 5. So we'll say that f of 5 is equal to 3 times 5 minus 2. Because we replaced x with 5 in the name, we have to replace x with 5 in the equation. Now we can simplify. F of 5 is equal to 15 minus 2. F of 5 is equal to 13. This is the x value. This is the y value. So we can say this is the ordered pair 5, 13. In example 6, it says create a table of values for the function g of x equals 4x plus 1 using the following x values, and we're using -2, -1, 0, 1, and 2. So you start by drawing your x and g of x columns instead of x and y, and they gave you the x values to use. And now you plug each of these x values into the equation as we did in example 5 up above. So if we plug -2 in for x, you get 4 times -2 plus 1, which gives you -7. And that's how the table is generated, and each of these lines shows the substitution for x and the output that corresponds to it. So -1 and -3 make the ordered pair. 0 and 1 make the next ordered pair, 1 and 5, and so on, 2 and 9. That is the end of this presentation for our introduction to relations and functions. You can go back, rewatch it, pause it, take notes, and then move on to the practice.